when you're finding an inverse of an equation, like if this says f of x, that stands for y, and you switch that to x, and you switch that y to, or that x to y. So you switch x and y, and then you solve for y. So you're going to add 7 on both sides, and then divide by 2. When you divide by 2, you can put it all under 2, or you can do it separately and do x over 2 plus 7 over 2. It just depends on how the answer choices might be written if that was a multiple choice. You could also graph it, graph what you think the inverse is and what the original was, and you can check and see if they look like they would flip over the line y equals x. Okay, in B, similar problem, f of x is y, so I'm going to make that x, and I'm going to make the x y. I want to get y by itself. Okay, so we're going to add 5. Divide by 2. Again, don't forget that you're dividing everything by 2. You could divide it separately or all at once. And then to get rid of the cube, you take the cube root. And it's all under the cube, or the cube root is over it all because you did it last. It's possible that, like, if you had a number here minus 5, that you would do the cube root in a different order. And so just be careful, it's not always over all of it like it was there. It just depends on the problem. Alright, number 21. I'm going to do 21 on paper just because I don't feel like I have room right there. But what you start off with is we're going to do synthetic division. And I'm going to change the sign, so that'll be a -3. And then these things go out beside the -3. Notice I'm missing an x squared. And there's also a k there, but don't be surprised by that. That just means there's going to be a k. So it'll look like that. Bring down the 1. Multiply and add. Multiply and add. Multiply. When you multiply, be careful and make sure you multiply -3 times both things. And then you add that, so you get -3k minus 24. Now they tell me in the problem that the remainder is 0, and we're looking for k. So when I find k, I'm setting, when I find what I got for the remainder, I'm setting that equal to 0 because they told me the remainder is supposed to be 0. So then I add 24 on both sides and divide by -3. That was supposed to be a -k. So yes, this is a negative here, which makes that a -k plus 9. So when I multiply, that changes that to a positive 3k like that. Yeah. And that just means that we get a positive 8. Thank you. Yep, do be careful about little things like that. I totally just messed it up as I was copying it to my paper. Alright, 22 is a similar kind of question. -2 will go in the box. Then we'll have 1, another 0, -2, and -3k. The only time I put letters up here is if there's k's or other letters, but not x's. X's never go up there. Okay, we multiply and add. Multiply and add. Multiply and add. And then I take whatever I got and I set that equal to 4 because it tells me the remainder is 4. And then I solve that, so add 4 on both sides. Divide by -3. And I get -8/3. Any questions? Alrighty. Next is a long division problem. I'm going to do it a long division way, but there is a shorter way, and it's not something we've talked about, so I wanted to show you that after I do it. But we're going to start, I know it's long division because there's a number in front of the x. So I'm going to take 2x plus 4 and then divide that by the whole thing. Alright, we're going to multiply or figure out what we multiply 2x by that will give me 2x to the third. That will be x squared. So then multiply both of those by x squared. 2x to the third plus 4x squared. Once you multiply, then you subtract. So I subtract that and subtract that. That's negative 7x squared. Bring down our 4x. 2x times what gives me negative 7x squared? Be negative. And a lot of you wanted to put 3 because that's close, but you need it to be exact. And that's what makes that one a little bit tricky. It is negative 3.5 because 3.5 times 7 will give you 7. 3.5 times 2 will give you 7. So that's negative 7x squared. 3.5 times 4, I don't even know what that is. It is 14. So that's minus 14x. We're going to subtract or change our signs. So we get 18x. Bring down that 5. 2x times what will give me 18x? 9. Then we multiply by 9. And then we subtract. So our remainder on this problem is negative 31. Now, I want to show you real quick, you can do this with synthetic division, it's just kind of weird. Okay? So, you see how the 2x plus 4 that you could do, factor out of 2? Like that's 2 times x plus 2. See that? So what you can do is you can divide by negative 2 with synthetic. And I'll have to explain the answer though. It doesn't come out exactly the way we want it to. Bring down that 2. Multiply and add. Multiply and add. Multiply and add. Look at our remainder. It came out the same. Now, our answer didn't come out the same. Our answer is twice whatever we started with. Okay? If you do it with synthetic and factor out a 2, you then have to divide those by 2 but not the remainder. The remainder comes out to be the same either way. But if you had to find the answer, you would have to divide each of those by 2 to work it out. So, I just wanted to show you that, if that makes sense, that's another way. If long division makes sense, long division is easiest. That way you don't forget some of the things that you might have to forget. But any questions about that one? Alrighty, next. This is totally a Desmos question. I would first graph it in Desmos. These are tables, and I want you to remember that you can put tables in Desmos. You go to the plus and you go to table. That's not 4. And so there's one of the tables. There's one of the way the points look. And then you could graph the equations to see if any of them go through that one. It doesn't look like it's that one. But that doesn't go through all of them, so it doesn't seem like it's that one. That one looks like it goes through all of them. So that first one must be number 3, or A there, however you want to write it. Does that make sense? There's another way to do it, but that's like the easier way, just because you could just look at the table and the graph. Let's look at the next one. There's one extra, so we know that it won't match up exactly. There's our points. We know it's not this one. I'm going to go ahead and take that one off. Doesn't look like it's that one. Yeah, that one doesn't go through that point, so it doesn't look like it's that one. That one might be the one that doesn't really work. So let's check the next one. Okay, there's our points again. That one doesn't go through both of them. Neither does that one. Uh-oh, we're struggling here. Well, let's go back and put in B. Maybe I put in something wrong originally.
The B graph is the y.
Oh yeah, maybe I had something wrong originally. Yep, the black one definitely matches the B graph.
Well, there's an extra graph. So then you put that one.
So this one was number 1, which is B. And so hopefully that matches, since when we did C, nothing matched there. I'm going to go ahead and take off that one. We know it's got to be this one, but let's just check and make sure. It does have to go through every point, not just some of the points. So you have to check each one, unfortunately. Yep, that one does match, so that's good. Alrighty, so the next question is asking me to find the circumference of the circle, and this is where it's important to know those formulas that we've talked about. The circumference is 2 pi r, and although they don't tell me r, they give me the equation. You could graph it if you wanted to find r, or just know that r is the square root of 4, so r is 2. And so in this case, the circumference is going to be 4 pi, or you could put 4 pi in and find that decimal. Be about 12 or 13. Okay. Questions about that? All right, number 26. So they gave me 2 points and they want me to find the equation of the circle. What I want to do is I want to graph it. You can graph it on the graph paper you're given, or you can graph points in here. You can just like put them in. You do have to put the coordinate pair, like the parentheses and everything. You could graph them and then let's see. Alrighty. So if that's them, where would the center be? Well, the center would be right there. Do you agree? So the center looks like it's going to be at 4, 5. And then if the center is at 4, 5, how much do I go from there to match it up? 3? So radius is 3. And then so to write your equation, we would have x minus 4 squared plus y minus 5 squared, square the 3, and you get 9. And then you could graph it just to check it, make sure it goes to those 2 points, and that they would be at the end points. All right, 27. 27, in my opinion, is one of the hardest ones on this part of the sheet. We've not done one like it, although the question doesn't seem too difficult. It is kind of weird. So when I start with 27, it tells me that the area is 9 pi. All right, if the area is 9 pi, and I know the area is pi r squared, I want to try to figure out what r is. Well, I can just kind of look at it and tell, or I can solve it, divide by pi on both sides, and then take the square root. Now I know r is 3. The radius is 3. That's helpful. It also tells me the arc length. And the arc length, if you remember, is the part of the circumference of a circle. It's 2 pi r times whatever the angle is. In this problem, we don't know the angle. And divided by 360. So they tell me in the problem that the arc length is 3 pi over 2. We know that r is 3. And so now I have this equation that I'm trying to solve. Now, you could actually try to solve it if you want to, like try to multiply and divide. I just want to remind you that you can solve equations in Desmos. 2 pi times 3 x divided by 360. And then instead of equals, I'm going to put minus 3 pi I'm going to have to put a parenthesis around that 3 pi or it won't divide it correctly. Divided by 2. And then I could find out where it crosses the x-axis. It's way out here. And I get 90 for x. So my angle where that is true is 90. This is another one we haven't really solved in this way, but we have done area of regions before, just not of the shaded region. So what I want to do is I want to start by finding the area of the whole circle. Okay, I know area of a circle is pi r squared. What's the radius of the whole thing? 11. It's supposed to be that 11 right there. So pi times 11 squared. Well, what would be the radius of just the little part, the white part? 3. So I want to take the whole thing and I want to subtract pi times r squared for the little part. And whatever I get right there, that would be the area that I'm looking for. So let's find out what that is exactly. Pi times 11 squared minus pi times 3 squared. And I got 351.9. Any questions about that? Alrighty, next it wants me to find the diameter. And this is some things about the circle that just remind you that you can use Pythagorean Theorem. They've already got our 90 degree there, so I know that Pythagorean Theorem is important. So I just do 7.3 squared plus 4.6 squared equals x squared. And whenever I do that, I'm going to take the square root of the 74.45 to get x, which is 8.628 or something like that. That's fine. Alright, number 30 wants us to find x. Now, there's a couple ways to do it. I saw some of you, how you did it was easier than what I would have done, so I want to show you your way because I thought it was easier. You do need to know that that is a right angle because this is a tangent and a radius. Okay, so you start off by finding the Pythagorean theorem, 12 squared plus 16 squared equals this whole side squared. Maybe we want to call that y, not x, because x is just that part right there. So 12 squared plus 16 squared, and then take the square root. What I get is that this whole thing is 20. Now, I need to find x. So in order to find x, I really need to know this part right here. Notice that this is the radius of a circle, and that is also the radius of a circle. This part right here is 12. Since the whole thing's 20, and that part is 12, I can subtract 20 minus 12 to get x, and that tells me that x is 8. Now, that's maybe an easier way to solve it. Some of you did it a different way, which works too, but okay. Number 31. So this is when we're looking at segments, and we're looking at segments outside the circle. So what we do is we take the number on the outside and multiply by the whole side. 7 plus 5 is 12. And we equal it to the other side. There's only one part, so we square that. So that would be x squared. 5 times 12 is 60. And then so to solve for x, we take the square root of 60, and we get 7.7. Okay, so some more circle type problems. When you're looking at the segments inside the circle, this is where you multiply the segments on the same segment together, 12t. And then you multiply these two segments together. Just make sure that 10 multiplies by both of those. 10t plus 60. Subtract 10t. Divide by 2. And so t is 30. 33 is a very weird one. Because actually that's a Math 2 question. But for whatever reason, I think maybe it's important for you to know this one too. This line right here is called the median. And I know it's the median because these two sides are the same and these two sides are the same. And what a median is basically is it splits it in half. So if this is 21 and that's 35, I'm finding the number that's between 21 and 35 that go right there. That's what I'm looking for. Okay. The way to find it is to take 21 and 35, add it together, and divide by 2. And that gives me, is it 28? Any questions about that one? Called the mid-segment. I think I said median. It's a mid-segment. Okay, next. The equation of the volume of a cylinder. We talked about this last week. Remember, it's area of the base times the height. Well, the area of the base here is pi r squared because the base is a circle. So it's going to be pi times 3, which is the radius, squared, times the height, which is 9. You just multiply that together, and you get 254.5 or 0.47, some way like that. B is a similar question. The difference is that they have x's in there, so it makes it look kind of weird. We still want to do area of the base times the height, so we still want to do pi times r squared, 3x squared, times the height, which is 6x. And that looks really weird because it has all these x's in it, but that just means our answer is going to also have x's in it. So what we do here is we square the 3 and the x, and then we multiply it all together. 9 times 6 is 54, and then our x's make x to the third. And we would leave our answer like that because there's x's and you can't really do anything with those. Okay, next. The density of a subject is, or substance, sorry, is mass divided by volume. We know the mass. We know the density. We're looking for the volume. So density is mass over volume. We know that our density is 2. We know our mass is 10, and we're looking for the volume. So basically we want to solve that equation. You can do it on Desmos. I will show you Desmos, and then I'll show you the other way too. But you just put in the 2, subtract your 10 over V, or 10 over X. Home will always take you back to the standard if you need it. It looks like our answer is going to be 5. The way to do it if you didn't use Desmos is to cross multiply. So put that over 1. You get 2V equals 10, divide by 2, and then that will give us the 5. That's another way to solve that. Okay. Population and sample. Oh, let's not skip our perimeter one. This perimeter one's a kind of strange one too. So when I talk about the perimeter on this problem, it's asking me the length of this, the length of this, that, and that. Perimeter is all the way on the outside. It's not any part on the inside. Okay, it's just all that outside stuff. So from here to here is 20. I need to figure out what from here to here is. That would tell me that. And then I'll have to figure out this part right here. Okay. I know that this is 7. That's the diameter of that part of the circle. So that means that this is 3.5 and this is 3.5. If those are 3.5, how would I figure out just that part of the rectangle? Subtract 20 minus 3.5 minus 3.5. So that's going to give me 13 up there and 13 down here. So my answer is at least 26. It's bigger than 26. So then to figure out this part from here to here, that is, when you find a perimeter, that's like the circumference of a circle. Okay? So that's 2 pi times r. However, that's not a whole circle. How much of a circle is it? Half of it. So I divide that by 2. And then I get pi times 3.5. So this part of the circle is approximately 10.99. Well, how much is that part of the circle? Same thing. So technically you wouldn't have had to divide it by 2. You could have just realized that that together made one circle. Or you can divide by 2 and then do it twice. So then to get my perimeter, I'm going to add 2 10.99s and 2 13s. And my perimeter comes out to be, where am I going to write it? 47.99. When you're talking about the population in the sample, population is like the whole group, sample is the part of the group. So when I look at this problem on A, 38 nurses working in the San Francisco area were surveyed concerning their opinions of managed health care. What would be the sample? At 38 nurses, because that's just the approximate amount, or part of the amount. So what do we think the population will be? All nurses, and it could be all nurses in San Francisco, it could be all nurses in America. We're not real sure where because they didn't give us a lot of information, but it's more than 38 nurses, and it's probably all of them in San Francisco since that was the area we were looking at. Okay, B. A survey of 39 credit cards found that the average annual percentage rate is that. So what do we think the sample is going to be? The 39 credit cards. Whenever you talk about the sample, you might not always know the number. It might just say some of the credit cards or something like that. Just keep that in mind. You might not always know the number. But the population would be all the credit cards. Again, it could be all the credit cards in America. It could be all the ones in a certain state. It just would have to give you more information to answer that.